Let's try taking it up to maybe about 1500, see what happens. That's actually 1600, 1600 there now. Seems stable. I'm going to take it up to 2000.
Oh, look at that.
There's 2000. It's interesting structure in there, that's for sure. Let's bring it down again, see what happens. And rotates a bit, and otherwise seems to look pretty much normal, I guess.
Pretty much the same.
Full speed, here we go. 1000, 13, 1500, 17, 2000, 22, 23, 24, 2600, 28, 3000, 3300, 37, 37, 6, 3780, 39, 41. Holding together pretty good. I'm not sure what the plasma is doing. I've been watching the tachometer. We're around 4,000 RPM. Nice and stable. Everything is moving around the entire table. The apparatus has got its own mind as far as where it wants to go. Wow, look at that thing go.
Especially the beam that goes up.
Yeah, the one that goes right up in the middle, it's very determined to stay there. It doesn't hardly quaver. There's almost a harmonic in there.
A pulse, yeah.
Eh?
Like a pulse.
A pulse, like, yeah. This looks like wings, almost like a dragonfly from my point of view here. As we come to a close, the plasma rotates another couple of turns before it settles out, and it's using everything now.
Now the one that goes to the top, that's really something that must be, I don't know, must be a reason for that. Because it disappears as soon as...
Well, yes, that's a good observation. Well, there's definite geometric shapes at certain RPMs with the arms that come off the tendrils that come off that center post. They're like little ballerinas in there doing different moves, you know, do the rotating dance. Scary. Now the tendril has tended to sort of warp to one side of the way it's rotating. And as we rev it up a little more, we're up to about 1,000 RPM. And at one certain point, right about now, the tendril from the center of the globe goes straight up to the top of the globe. And there's no other tendrils in there, and that becomes similar, maybe even a little more intense with high speed. Take it up to 2,500, for example, and it's still one tendril. Take it up to full speed.
Something going on, huh?
Okay, now let's note this phenomenon that we've also noticed here, which is the central tendril that goes up to the top right now. As we lower the RPM, it'll tend to stay there much more stably. It's easier to keep it going than it is to get it going to start with, you might say. In other words, I can lower the RPM right down to a few hundred RPM here now, and the central tendril stays there right until probably about, well, it's still there, strangely enough. And now it's sort of there. It's locked onto the tin foil to the side.